Good morning, everyone. Thank you for joining today's webinar, Enterprise Asset Management Integrated with IoT and Predictive Analytics. This webinar is jointly hosted by Accrete Solutions and Efftronics. Accrete Solution is an SAP and Salesforce partner. They provide SAP Asset Management, SAP Field Service Management, and Salesforce FSL solutions. Efftronics is a provider of smart and innovative solutions for smart cities, buildings, signaling, and IoT solutions. Before we start, I would like to go over a few housekeeping items. If you have any question during the presentation, please type them into the question box in your GoToWebinar control panel. We will bring them up during the presentation, and we will also have time for questions at the end. This webinar is being recorded and will be sent to you following the presentation for your own purpose or to share with others. So now I would like to introduce today's presenters. We have Ashish Saxena. He is Vice President at Accrete Solutions. I would request Ashish to share a brief about his role and responsibilities in Accrete. So Ashish.
Hi, good morning, good afternoon, good evening, everyone. This is Ashish Saxena. So I am responsible at Accrete Solutions for global project delivery. I have about 25 plus years of experience in defining strategies and roadmaps for EAM, service to cash processes, customer service, parts management, and then implementation of the same using solutions like SAP, Salesforce. Prior to Accrete Solutions, I worked at KPMG and Berrypoint. And then I've been working in the maintenance side or service operations side before I started doing consulting. So I have experience of about 10 plus years in managing repair centers, field service operations, parts logistics, etc.
Thanks, Ashish. Now we have Anvesh Dasari. He is Vice President Efftronics. I would request Anvesh to share a brief about his role and responsibilities at Efftronics. Anvesh.
Good morning, good evening. This is Anvesh. Currently, I'm working as Vice President in R&D in Efftronics. I have got more than 12 years of experience in building IoT devices and systems. In Efftronics, we have developed more than 50 plus IoT solutions. Today, Efftronics is recognized by Gartner as a representative vendor for building industrial IoT gateways. I'm also a member of Forbes Technology Council. Thank you.
Thanks, Anvesh. We will start this webinar with a short poll. So I would request you to please respond to these polling questions that we have for today. So here we go with our first poll question for today. It's about your plans about digital transformation initiatives in your organization, the timelines in which you are planning. We have another question, poll question that is related with challenges you are facing in asset management. So whether it's about maintenance, finance, parts management, safety. Here we go with our third poll question for today. The EM solution you are using in your organization right now. And here we are at last question. It's about the IoT solution that you are looking at the timelines. Thank you. Before we start, let me share what we would have in today's session. So primarily we divided that into three sessions. One is presentation and case study. Our experts will discuss that. And in second session, we will showcase a live demo of integration of SAP EM with IoT. And the third one is question answer session. So now I will request Ashish to start today's presentation. Ashish.
Okay, so I'm going to talk about what is enterprise asset management, in the first slide, and then talk about what are the challenges and what are the enablers of enterprise asset management, what benefits and KPIs you should be measuring to run EM operations. So enterprise asset management basically includes maintenance of all high valued equipments or physical assets which an organization might have. This is definitely more true for asset intensive companies, especially companies like utilities or transportation or heavy equipment. It's true for other companies as well. And then another key component of EM is asset life cycle. So every asset has a defined life cycle in which you basically plan for acquiring an asset. Then you do the actual acquisition of the asset by placing a PO to the vendor, and vendor then ships it to you, and then you receive it, and then you install it. So installation process, the key process of an asset, and then you use the asset in a manufacturing location or any other locations, and maintain the asset, and finally the asset, after the asset life is over, you retire the asset. That's typically the asset life cycle. In EM operations, you probably want to consider things like asset 360 degree, which is like customer 360 degree. So you would want to know all the details about the asset, including what repairs have been performed in the past, what tickets or alerts you might have got for the asset, how is the asset performing, what has been the downtime, what is the MTBF, etc. This helps the technician performing the repairs, as well as it helps the organization holistically to measure key KPIs of the asset. And of course, maintenance activities like repairing, as well as tracking time for repairs, usage of parts, work orders, notifications, etc. Scheduling technicians for performing the work is definitely a critical component. Then parts management and parts planning. How do you forecast the parts? What's the logistic for the parts? Movement of parts between different warehouses or production capacity floors, etc. Then you also want to have some modules which are sent out to subcontractors for repairs. In a large machine, there not one vendor provides all the part. Imagine an airplane where you have parts from GE and other vendors as well. So parts could go out for subcontract repair, or you could have services provided by third-party companies on the equipment. And for all these costs which are incurred, you want to track the labor cost, you want to track third-party repair costs, you want to track all the parts cost, and basically measure what was the budget versus plan versus actual. And then a new component which has come up is IoT, AI, and ML. So many of the machines already have IoT devices, or you can have them installed. And these IoT and AI solutions could help in predictive maintenance instead of preventive maintenance, which is based on a fixed cycle, using historical information and some algorithms which we have. Again, Anvesh is going to talk more about the detail about the IoT solution, but it basically helps in reducing downtimes with assets communicating with various systems, as well as IoT tools, IoT integration or EM integration with SCADA and distributed control systems, CNCs, etc. Finally, you would also want to have permits, safety permits or work permits. So safety permit is, you are working on an elevator, you want to make sure a safety permit is there before the work on the elevator can be started. Work permits are more complex, so it's more like high voltage transformers where you need to have specific work permits, and there are special processes like lockout, tag out, etc. That in a nutshell is about an EM overview. And next I'm going to talk about what are the challenges in an EM environment. Next slide. So you can go through some of the challenges which are listed here. I'm going to address a few of them. Accurate maintenance data is key, which is basically relating to Asset 360, where you want to make sure that you have the consistent data across every asset, every department, every geography, and this can enable holistic KPI reporting. So you could have multiple systems. You could have one system for service ticketing, or or alerts or notifications. You could have another system for parts. You could have a third system for work order execution and planning. But all this really needs to be properly, either could be part of one system or needs to be gathered, and the information should be stored in one place so you can get a holistic view of the organization's asset condition and how they're performing. It will help you in defining KPIs like MTTR, MTBF, first time fix rates, higher uptimes, etc. The other challenge is that organizations have a lot of equipment on the production floor. So you have robotic equipments, you have sensors, you have other electronic equipments, and these equipments help in automation and streamlining the production processes, but they're quite complex. Imagine a large medical hospital which has multiple CT scans or X-ray machines. They're quite complex to maintain. Similarly, you have large turbines or large machines which are used for mining, etc. Those are quite complex and difficult to maintain. So although they are getting reliable, but getting them to maintain is going to be a challenge, and getting resources or skilled resources to do that maintenance is definitely a challenge. So things like periodic resource training, knowledge management systems where you can store all the historical issues which have occurred and resolutions for the same, and then remote diagnosis by experts can probably help in alleviating this challenge. So you could have experts seeing a video of the issue being troubleshot, and then hopefully they can help in the resolution as well. And then finally, another key challenge is how do you prioritize the work? There is a lot of maintenance work to be done, like things like inspections, things like repairs, things like parts planning, resource upskilling, etc. So how do you make sure that you have the right tools and at the right place at the right time, and you can do that in the budget which is allocated? This obviously is required to make sure the production floor is running smoothly and has high production output. So these are some of the challenges, and there are some enablers which have enabled EAM. in my opinion, data is the biggest enabler. So you have a lot of data coming in from all these connected machines using IoT. And so what do you do with all this data? And how do you use it, put it to good effect? So things like predictive maintenance, which I talked about earlier, as well as forecasting of parts. Since you have some historical information and you have product information, you would also forecast parts which may be needed for repairs. You could, based on the data, you could come up with new products which can be launched. You could also do outcome-based services, which essentially is, instead of selling a product, you're selling a service or a combination of a product and a service. And then availability of offline data and online data on mobile and cloud solutions. So the technicians can be in a place where there is no internet connectivity. They can get all the maintenance data, all the asset information, or even if there is internet connectivity, you still want them to have all the historical repairs and historical tickets of what has been done, and even what are the changes to the asset which may have happened. So mobile and cloud solutions enable that. The technicians can actually perform routine inspections, the actual maintenance, the parts used, as well as labor, get customer signature, track things like images of the equipment. All the work can be done using a mobile device for the technician. It helps in efficiency and productivity, plus it helps in saving the planet, that is less paper. Another key thing which is going on, probably would have heard of digital transformation. So digital transformation in EAM space is also quite popular these days. So in my opinion, digital transformation is defined as leveraging digital technology into all areas of the business, and that will help ensure customer value as well as smooth operations of the business. It can enable things like, in the EAM space, movement from reactive to proactive to automated to intelligent asset management. You can streamline the supply chain and forecasting of parts. You can also find new service offerings and new revenue generating models. For example, in the printer business, printers are no longer sold in the B2B space. They sell per copy, right? And then finally, SaaS business model enables lower cost and less complexities, and they can basically software upgrades and software patches and services can be performed by the supplier remotely with low risk and lower costs. So digital transformation does enables quite a lot of things in the EM space for the organization. Some of the benefits which you get from EAM is obviously, next slide. You can go through all of them, which is listed on the slide, but some of the key ones would be maintenance cost reduction, with IoT predicting what the fail will help in predicting when the maintenance should occur, would result in lower cost because, like a car, you have a car, you did preventive maintenance, like you do it once a year or you do it, every 10,000 miles. Instead of that, when the car tells you when it's going to fail, and then do the maintenance, that will reduce the number of maintenance as well as the maintenance cost. Then IoT and EM analytics will help in improved parts demand forecasting, which can help in just-in-time parts replenishment, reduced inventory. Obviously, reduced inventory means lower inventory costs, inventory carrying cost, and then obviously when you have reduced inventory, the logistics of the parts movement are also reduced. So that will help in. reduced logistics cost as well. Then as the asset life would be longer with proper maintenance and better quality of assets, you will have higher return on the asset. So higher ROA. And ROA is defined as net income divided by total asset value. Then another benefit is employee productivity with all the mobile applications and cloud solutions and digital processes. There is reduced data entry with the scanning and images, etc. And you can do a lot of work on the mobile. So that's another big benefit. Higher asset reliability, which will result in higher uptimes and which will result in improved production output with lower losses and lower downtimes. And finally, reduced safety incidents. So the number of safety incidents causes production downtime, and if you have reduced safety incidents, that will obviously reduce, and then it'll help improve employee morale and employee productivity. These are some of the benefits besides the one which are listed here. And then finally, what do you want to measure to run your EM operations? So what KPIs, next slide please. What KPIs you would like to measure in driving improvements in maintenance operations? So there are a lot of KPIs available, like maintenance cost, resource cost, quality, reliability, etc. But in my opinion, we should focus on KPIs which basically measure effectiveness and efficiency of people, tools, and processes. So things like how quickly a work order can be completed, which is basically MTTR, or what's the ratio of preventive maintenance to reactive maintenance, or how much downtime does your asset base have. So you could basically develop a dashboard which has the key KPIs which your organization would like to monitor. And you can see some of them listed on the slide, but some of the key ones are OEE, which is overall equipment effectiveness. Basically, it is availability multiplied by performance multiplied by quality, and it helps in depicting a picture of how your manufacturing is running. Things like MTBF, how frequently your machines fail, mean time between failure, MTTR, which is mean time to repair, or things like first time fix rate, etc. Like if a technician goes for repair, he or she should be able to repair the equipment first time and doesn't have to do multiple repair cycles. So with that, I would hand it over to Anvesh to talk about the IoT solution, what Efftronics offers, and how it works, and how can it help in predictive and analytics as well as the KPIs which I talked about. Anvesh.
Thanks, Ashish. Till now, we have seen the challenges, benefits, and enablers of EM. The key enabler of IEM is Internet of Things, IoT. IoT is becoming pervasive. It is going to be implemented in every vertical industry. If we look at some of the key statistics, by 2020, this year, Gartner predicts that more than 25 billion things will be deployed and ready to use. These devices will generate 50 trillion GBs of data. So it is very important for any asset intensive industries or enterprises like mining, transportation, high-tech industries, automobile, etc. to digitize their assets along with IoT. IoT will definitely drive business outcomes for any enterprise. Today, a lot of enterprises have various systems They have got their ERPs or other softwares which are working in silos. IoT will integrate these systems and make enterprises Industry 4.0 ready. As I said, IoT along with EAM will drive business outcomes. What are these business outcomes? These outcomes can be improving the customer experience, or creating new business models, or reducing the operating cost. Taking an example of reducing operating cost, how is it possible? We can improve the availability of assets in enterprise. How do you say that we are improving the availability of asset? We are getting real-time data, and this data is being crunched, and a lot of insights are available, and that helps us in improving the availability. How is the data generated? By using sensors and IoT devices. So these sensors and IoT will deliver a lot of data that is being crunched with analytics and machine learning, which brings us a lot of insights which are actionable, and this will deliver a lot of outcomes for the enterprises. Next slide. If we understood the benefits of IoT and power of IoT, let us understand how why IoT is required along with EAM. For any enterprise asset, availability is very key. Availability depends on two important parameters, that is MTTR, which is mean time to repair, and MTBF, which is mean time between failures. These are some of the most important KPIs which a lot of enterprises will observe. So for improving the availability of assets, various enterprises have various maintenance strategies. Those include corrective maintenance or run to failure, where whenever there is a failure, we go and repair it. Or there is a scheduled maintenance or periodic maintenance. The biggest problem with these kind of maintenance strategy is it is too expensive and also very inefficient. We are understanding that every asset is going to function in a similar fashion. But in reality, the usage of asset will differ based on the location, based on its outcome or the location. Like that, there are various parameters which will determine its usage and also its failure. So now it is very important to move from corrective and periodic maintenance to predictive maintenance. In predictive maintenance, that is only possible with IoT, where we are in real time observing the data coming from the asset and then predicting the failures beforehand. This is one of the vital or the best method of maintenance strategy, and this will clearly improve the availability of assets as shown in the graph, and also it will significantly reduce the maintenance cost of the asset. Next slide. Today, for the benefit of all the audience, we are going to present one of the use case of world's third largest railway transporter, which is Indian Railways. The total assets owned by railways is more than 50 billion US dollars. Every day, more than 20 million people commute over railways. These are the numbers before COVID. And also even today, more than 100 million tons of cargo is transported every month. And these numbers are increasing year on year. And if we look at the utilization of infrastructure in railways, it is more than 95%. So all these numbers suggest that or imply that any downtime of assets will create huge revenue loss to Indian Railways. And even it is estimated that every minute delay of train will create 500,000 revenue loss to Indian Railways. This clearly shows that availability of asset is very, very important for this customer. So here we have deployed IoT along with enterprise asset management, and we are helping railways to have better availability of assets. Assets in Indian Railways are two categories. One is movable asset and other one is static. In this slide, we can see the example of various IoT devices which are being deployed on the movable assets like locomotives, wagons, and coaches. So there are IoT devices which can track the GPS or the location. Some of the IoT devices are used to monitor the performance of doors or air conditioner, or similarly the track monitoring or the wheel and axle monitoring. Like that, there are hundreds of sensors to monitor the performance of each subcomponent of this huge asset. Next slide. So we have seen some of the IoT devices deployed in movable assets. Similarly, railways have got a lot of static assets. These assets are infrastructure assets which are used to run the trains. Those are tracks, electricity or the OHE, and then there are some assets called signaling which are very important for collision-free movement of trains. So here in this station, we can see various different kinds of IoT devices. Those are IoT edge systems. Similarly, we have some sensors to monitor power, batteries, signals, and so on. And each asset has got different IoT devices and different kinds of sensors. Next slide. Today, in this webinar, I'm going to focus on one key asset on this company or the customer called point machine. Point machine is very critical asset of railways. This asset is used in railways to move a train from one track to other. This is having a mechanical part which is controlled by a motor. If point is not operated, the trains cannot move from one track to other. Similarly, if the point is not positioned correctly, it can create derailment of train. This is a biggest safety hazard, which is having a loss of, having a life risk. So this asset is very vital for safe running of trains as well as punctuality of trains. So today we have monitoring thousands of these point machines in Indian Railways. On to my right, we can see the IoT device which is deployed in the field to monitor this asset. This IoT device is equipped with multiple sensors. The sensors include current sensors, voltage sensors, vibration sensors, and temperature sensors. This IoT device is connected to our IoT platform through various connectivity mediums. There is a provision to connect through GPRS, which is like 4G or 2G or 3G, or it can also work on free ISM bands using Zigbee technology. And this IoT device will be connected to the IoT platform where the machine learning and predictive analytics are going to happen. This IoT device connects to IoT platform through multiple protocols. Those protocols include like MQTT, CoAP, or Modbus, or industry standard protocols for railways like ULINX. So this is how this device is connected to the IoT platform. Next slide. So we have seen how the asset is being monitored in real time in the field, and also it is completely non-intrusive and we are not disturbing the asset. Now in this slide and next slide, I'm going to talk about how the predictive analytics are going to work. Predictive analytics has got two parts. The first step is training the system. So we have the asset, that is point machine, which is equipped with an IoT device, and this generates a lot of data. This data is interpolated and we create a lot of clusters. Clusters are nothing but various signatures. Normal operation of a point machine is one kind of a cluster. Failure A is a cluster. Failure B is a cluster. Like that, we create several clusters for various different signatures and scenarios. Then these clusters are trained to the machine learning, and we have used random forest algorithm. Then this algorithm is stored in a tool called Pickle, and we deploy with an API. Next slide. This is how we train the model. Now, in real time, what is going to happen is the asset we are talking about, the point machine, is in the field, which is equipped again with the same IoT device. And in real time, it is generating a lot of data, the ones and zeros. And then first we interpolate and create the signature. This is like a signature of like a heart ECG. Like the heart has an ECG. Similarly, this is a current signature of a point machine to know its healthiness. Then this signature is given to the AI, and in the AI, it is going to compare the current signature with the cluster of signatures. If it is correlated with any failure, it is immediately going to trigger an alert to the SAP system through API. This is done seamlessly and in real time. Once the API is triggered in the SAP system, it is the SAP system, SAP EAM system is going to generate ticket. Then work order will be created and a technician will be allocated with the work, and the technician can go to the field and he can take the inputs from the data, like what is the failure, and even before going to the field, he can equip himself with the parts required for the repair, and he will equip with all the required parts, and then he will go to the field, directly go to the part where it requires the maintenance, he will repair it, and then he will submit the report of the corrective action again. Again, with all this data, we update the KPIs which Ashish has talked previously. So this is how IoT is enabling the EAM, and lot of manual interventions are being automated with IoT. So we have seen how an IoT and EAM are working seamlessly. Similarly, EAM can also be integrated with FSM. This will enable OEM to improve the performance of their products. And even to tell you, IoT is also called as system of systems. That means multiple systems are working concurrently. Here we have the assets, we have an EAM software which is working in together. Similarly, the EAM software and FSM software, two different systems, can also be linked together and can work seamlessly. Now, Ashish will talk about these two systems in detail. Thank you.
Thanks, Anvesh. So as I talked about earlier as well, the enterprise asset management overview. SAP S/4HANA, which you see on the left-hand side, supports all the areas or modules within EAM. So things like inventory management, asset 360, finance, spare parts, logistics, planning, purchasing, as well as safety, integration with IoT and OT. All that stuff can be done easily in SAP S/4HANA. We also have solutions like SAP Field Service or Salesforce Field Service Lightning. So as you would probably know that enterprise asset management is typically assets owned by the organization, maintenance of that. Field service is you sell the organization, the assets to a customer who can then, for whom you maintain the assets. Also there's in between wherein your equipments like can also be at a customer site. So it could be in the transportation business, it could be in the mining business, wherein the mine doesn't buy the equipment, but basically has it installed, and then they basically pay it based on the usage of the machines, but it's maintained by the manufacturer. So we probably are one of the very few vendors who have a very good depth in expertise on enterprise asset management as well as field service and the solutions needed for integrating and making the solution work. So even in field service management, you have things like service ticketing, work order execution, scheduling, parts logistic, invoicing, customer signature. So the solutions for SAP Field Service Management, which is basically a mobile app application, as well as a SAP Field FSL, can be integrated with SAP S/4HANA as a backend for the field service part of it. Next, I'm going to talk about the architecture of high-level architecture of how the whole thing would work. So if you look at the bottom right, you can see the assets. The assets which have IoT device are either IoT device enabled or IoT devices can be added to that. So Efftronics does provide IoT devices which can be installed on assets which don't have IoT devices. They get the data, IoT data, using the Efftronics gateway into a Efftronics IoT platform, which is what Anvay just talked about. And that data can be fed through the SAP Cloud Connector, either to Asset Central Foundation or directly to SAP S/4HANA. So you could have APIs directly calling SAP ERP system. S/4HANA, if you are not aware, is a ERP system. And then you also can have FSM application, which is SAP or Salesforce FSM, interacting through the cloud platform, through the cloud platform connector to SAP S/4HANA or directly using APIs as well. Then there is SAP Asset Manager, which is also a mobile application but that is used more by internal folks who are maintaining equipments in a production facility. So both these applications have a lot of maintenance capabilities and information on things like assets, the geolocation of the assets, as well as historical data about the assets, what tickets have been created in the past, repair order history, parts usage, tracking of time, taking images and pictures, taking customer signatures if need be, attaching operational steps. So what are the steps to perform the repair, etc. Inspections, etc. All this stuff can be done using these applications. On the right-hand side is S/4HANA, which is a ERP system where you have different modules, which includes enterprise asset management, it includes fixed asset accounting, it includes warehouse management, inventory management, material management, BOMs, purchasing, subcontracting services, as well as parts. And then you also have order management, which includes shipping, returns, as well as sending parts on consignment, etc. On the left-hand side, you see Asset Central Foundation. So Asset Central Foundation is a tool which where all the data which comes either from SAP S/4HANA or from these IoT or mobile applications is stored. So all the equipment records, the functional location, the install base, as well as notifications, work orders, parts, etc., are stored in Asset Central Foundation. So that's the place wherein you can get all information, and that information can be bidirectional and can be distributed to certain system or received from certain systems. So in this case, SAP has also developed a tool called SAP ASPM, which is basically SAP Asset Strategy and Performance Management. This part was missing in SAP ERP. So this helps in plant managers or production floor managers to measure and improve the performance and of the asset and optimize maintenance strategies. So it has asset management strategies like risk and criticality analysis. You can basically classify assets based on its criticality and also define a risk score for those assets. Another methodology is failure mode effect analysis, wherein you can analyze reliability issues and what actions to be taken for that. Things like identification of failure modes and what is a maintenance strategy to fix that failure. You can also define checklists and inspections, which can be seen in the SAP Asset Manager mobile app. So you can define it there, and then the data can also be shared from the Asset Manager back to SAP ASPM. But the mobile app can display a checklist or an inspection. It can also display calibration or linear assets, as well as the calibration readings really come from SAP ERP. So some things come from SPM, some things come from S/4HANA. Then another solution which is again cloud-based is SAP Intelligence Network, which is on the top left. That is a tool which has been developed for collaboration. So imagine Boeing's aeroplane, which has multiple modules like wings, like engines, which are made by different vendors. So those vendors can collaborate with Boeing, as an example, and provide update on bombs, engineering change notices, parts, asset update, and changes to the asset, etc. So it's basically real-time information sharing between the organization and its vendors for maintaining the complete asset life cycle as well as asset history. You can also perform reporting using SAP Cloud Analytics, using data from S/4HANA and sources even from ASPM as well. There are some predefined KPIs which are available, which you can leverage, or you can build your own KPIs on that one. So I've talked about high level about the architecture. Now we're going to show you a demo. So the demo would probably comprise of a point machine, which is installed at a station, and that data has been maintained in SAP and has been replicated to Efftronics system, which using its Efftronics platform or IoT devices will feed in data. So I'm going to hand it over to Anvesh so he can talk about it.
Thanks, Ashish. So as I said, the EM software has got the details of various assets. And here we are talking about static assets. And this is a customer railways. In the railways, there are multiple stations. In India itself, there are got 7,500 stations. And today, all the stations are equipped with these IoT devices. For the demo, we have only showing the data coming from one station in India, called Gannavaram. So this station is equipped with a IoT device from Efftronics, as well as the device ID is 70. Once this device is configured, there is a API interface between SAP system and also this IoT platform to understand the configuration of assets and also complete asset database. Once that is done, we have got the real-time data flowing in. For the demo, I have taken little few hours of earlier data. So here we can see data coming from the IoT device. This is the timestamp of the records. And then we can see that here we are talking about one asset called point machine. So here there is only data, one asset configured. So this is the data coming from the asset. We can see that this is the current signature. So at peak, it went to almost 10.3 amps, and then there was various current readings. So this is the timestamp at which we got the signature. So this is the graphs and also the data coming from the IoT device. If there is no failures, there is not going to be any false or notifications. But here we can see that there is one failure which is related to 0.201, which is triggered automatically based on the machine learning which is running in the background. So the machine learning algorithm will continuously understand the signature. It will compare it with various clusters. If it is matching with any failures or predictive failures, it is going to trigger a notification. This notification is now going to be triggering an API alert directly to the SAP EAM system. So now I will hand over this to Ashish to show that this alert is linked to EAM, and then the process continues in the EAM software. So let us see from there.
So thanks, Anvesh. So now you're looking at SAP S/4HANA on something called an asset viewer. Asset viewer basically is like an asset 360. It has all the information about an asset. So we are looking at something called a functional location or a location, which is basically Southeast Railway's Gannavaram station, which is what Anvesh was talking about. So at this location, on the left-hand side, you can see you have equipment installed. So the equipments, things like axle counter, level crossing, there are multiple point machines. And in this case, a failure has happened on point machine 1, which is ending with 1024. So we'll go into the details of that equipment record. And you can see this equipment record has a status called INST, which is basically saying it's installed at Gannavaram station. At the bottom, you can see things like manufacturing. It was manufactured by Siemens. What's the model number for Siemens? Where was it manufactured? What's the month and year of manufacture, etc. So you can maintain a lot of information like size, dimensions, when was it started using by, what's the weight, etc. So you can have your own dimensions as well. Now you also heard Anvesh talking about point machines having some measuring points. So basically, measuring point is a location on a device from which you can get measurement readings. So, I mean, in a car, for example, you could have engine providing heat. You can have, speed coming from the tires, and you can have, pressure coming from the tires. So there could be multiple measuring points in the machine. So in this case, we're talking about three, I mean, last one is a test one, but you could have a measuring point 23, which is location box 1, and 24. Basically, measuring point 1 is used for current measurements, and measuring point 24 is used for voltage measurements. So in this case, if you click on 23, you will see the measurement readings which you have got from the device. So if you can see, we have multiple measurement readings which have come over, and we'll open the last measurement reading, which is 222, and see what came over from Efftronics. So the measurement reading says is current. You can see on the bottom side, and the reading was 11 amperes. So you can store this reading in SAP. Again, you don't have to get all the measurement readings or measurement readings every time, but you can define the frequency when you need it. It basically helps in, so there are situations wherein the technician had to go to the equipment site to take the measurement readings or calibration readings. That information actually can also be fed in from the IoT devices back into back-end EAM systems, which can then be used for various purposes like maintenance, etc., or other things as well. So that was the measurement reading. Plus, since the machine was down, a notification was also created. So if you go to the order notification tabs, so you can see all the notifications which have been created. So in which this is seems to be a point machine which has failed quite a lot. Anyway, I'm joking. It's probably because of testing done by our team for integration purposes. But before you go to the details of the notification, you can see in the asset viewer, there is a task list, there are documents which you can assign, you can have maintenance plans, you can have permits, safety permits, work permits, etc. So pretty much you can have all the details about the equipment in one place. Additional tabs can also be added. So in this case, we're going to just right click on the notification 541, which was created just now, and that will take us to the details of the notification which was created. So as I said earlier, the equipment records and the functional location records have been replicated to the Efftronics system, and that is why we are able to get the equipment number from the Efftronics system as well. In addition, we have also sent over as a one-time upload, download from SAP and upload into Efftronics the failure code catalogs, the damage code catalogs, etc. I'm going to show you that soon. So if you look at this, you can see that there was PT201A end obstructed, which is what you saw in the Efftronics system as well. The required start date is today's at 1852. That's probably India time it's showing. And that's when the notification got created. So it was a real-time alert from the device, which came over through the IoT platform into SAP, and the technical object, which is the equipment, point machine, and the location, which is the Southeast Railways, is shown here as well. Then on the right-hand side, you can see what's the priority. An estimated end date is also there, which you can define. Assigned work order, when the work order is created for this, you can see the work order, but that will be done later on. So next, we're going to look at the location data, which is where the machine is located, which you can see is in Gannavaram. And then we'll go to the malfunction data. So this is where you can see that this was a breakdown. So you can see the breakdown indicator checked. The start time was recorded as well, and the end time will be when the malfunction is complete, or repair is completed. That is how you can calculate MTBF and the other KPIs. And then on the right-hand side, you can see the object part. So the motor of the point machine had a failure. That is what has come from Efftronics system. You can also see the damage code, which is object brush failure, sorry, motor brush failure for that motor. And then in the cause is improper maintenance. So all that information has come over. Now, what will happen next is this will be sent for repairs using a work order. So the system can automatically generate a work order, or you can manually create it. And the work order then would be assigned to a technician who will then perform the work and close out the close out the repairs. In that case, what will happen is you will track all the actual damage code and cause codes, compare it with what Efftronics provided, and see if there are any variations in that as well. And you can track parts usage, labor usage, etc. That in a nutshell completes our demo, and I'll hand it over back to Ajay now for any questions, probably time.
Thanks, Ashish and Anvesh. We are almost at the end of today's session, but still, we will take, I think, a couple of questions. And for the rest of the people, we will reply through email. So we have first question is related to security concerns. So how to handle the security concerns while deploying IoT for EM? So Anvesh, if you could take this quickly.
Thanks, Ajay. It's a very good question. Security is very big concern and challenge with IoT. So there are multiple practices to deploy the security. One is the protocol with which we are sending the data from IoT to the IoT platform can be encrypted. So encryption of the data is the first step. The second thing is configuring or accepting the IoT devices or the data coming from a approved device. That means there should be a authorization for whatever IoT device we are deploying into our IoT platform. Again, there is a key generation like that. There are many strategies available in security, which can also be implemented in the IoT device. Similarly, in the IoT device also, the silicon vendors are now coming up with a lot of security measures. So choosing a right IoT device to monitor our asset is also very important to have a secure network and secure data. Thank you.
Thanks, Anvesh. We have one more question. Do you have any kind of best practice process flow for asset management, maintenance, and field service? So maybe Ashish, you would like to take this question.
Yeah, so we do have industry-wise best practices, a list of KPIs. We do have list of capabilities. We do have process flows for service ticketing, maintenance, repair, actual work, actually repairs, parts, invoicing, if for customer in that case, or scheduling, parts management, parts logistic, etc. So we have end-to-end process flows and how they should work. We basically use that for defining a high-level roadmap, and then during the design phase, take it into more detail level and get the customers' process flows. Hopefully that answers the question.
Thanks, Ashish. So we are at end of today's session, but still there is one question: how to make a legacy machine or equipment IoT ready? So Anvesh or maybe Ashish, both you guys can reply.
That's a very good question, Ajay. So now enterprises have already invested millions and billions of dollars on a lot of assets. So we cannot directly buy a new asset or a replacement, but there is a solution to make a lot of legacy systems IoT ready. There are two methods. In method one, there is diagnostic ports available in a lot of assets. So we can connect to those diagnostic ports using protocol converters. This will convert the data coming from the diagnostic port. There are like Modbus, BACnet, or EtherCAT. So we take the data from various available protocols and push it into the IoT platform. The second method is there are so many thousands of different sensors available in the market. We will put these sensors along with our IoT gateways and capture a lot of real-time data to understand the behavior of the asset. So these are the two important or available ways to make a legacy asset to be an industry or IoT ready. Thank you.
Thanks, Anvesh. Thank you, Ashish, Anvesh, for sharing insight on EM and IoT-enabled asset management. And thank you, everyone, for attending today's webinar. You will receive a follow-up email with a link to view a recording of today's webinar. And there are some questions left, so we will reply on those questions through email. On behalf of Accrete, Efftronics, and our presenters, thank you for joining us today and have a nice day. Thank you, everyone.
Thank you.
Thank you, everyone. Thanks for joining.